Welcome back, everyone. Today we'll be deep diving into the 8 basic data types of Python, which are integers, floating point numbers, strings, lists, sets, dictionaries, tuples, and Booleans. Data types are the fundamental building blocks of your programs. By the end of this video, you'll have a solid understanding of how and when to use these data types. Let's get started. First up, we have int, or integers. These are numbers like 45, -10, and 100, basically numbers that aren't decimals. Simple, right? To show you an example, I'll open up my Python interpreter and create a variable called age, which will be set to 54. Now let's print the type of age. The type function basically returns the type of data type something is. When we hit run for the variable age, you can see that we get int. Now let's try negative number. Let's make age set to -35, and let's hit run again. As you can see, age is still an integer. Now we've got float, a short term for floating point numbers. The float data type is all numbers that are decimals, like 2.1, -14.6, or 99.99. Let's go ahead and print the type for the number 99.99. As you can see, we get float. Now let's try -14.6. We also get float. Floating point numbers are all numbers that have decimal points. Next, we have the list data type, which is a collection of items enclosed in square brackets. It can contain elements of different data types. Lists are ordered and allow duplicate values, and they are commonly used to store and organize related data, making them a fundamental data type in Python. For example, let's say we have a list of groceries we want to buy. But if we do not use a list, we would make many variables called food1 equal to apples, food2 equal to milk, food3 equal to cheese, so on and so forth. But if we had a list, we could just create a single variable named called grocery list and set it equal to empty brackets. Apples, we separate them by comma, apples, milk, and cheese. And we would go on as much as we need to. To access elements of a list, all we need to do is use the subscript method or use a for loop. For this instance, we'll be using a for loop, so I'd start up by saying for groceries in grocery list, print groceries. When we hit run, you can see that we get everything we had in our grocery list in the output. Next, we have sets. Unlike lists, a set is an unordered collection of unique elements enclosed in curly braces or created using the set function. Sets are used to store multiple items without any particular order. For example, let's create a set called fruits and set it equal to an empty set with elements of apple, banana, and orange. One of the main advantages of sets is their ability to perform set operations such as union and intersection. To show you an example of this, I'll create another set called fruits2 equal to grapes, straw, berries, and pineapple. To perform a union of these two sets, all we need to do is print fruits.union fruits2. When we hit run, you can see the combination of these two sets, all in one set. To perform an intersection of these two sets, all you need to do is fruits.intersection fruits2. And as you can see, there's none because there's nothing that is in both of these two sets. But to fix this, for example, I can put banana in here, and we'd get banana as an intersection of these two sets that relates them together. Sets are commonly used in scenarios where you need to eliminate duplicates or check for membership of an item in a collection. Next up, we have dictionaries, which are a type of data that store a collection of key value pairs. They're also known as associative arrays or hash maps in other programming languages. In a dictionary, each key is unique to an associated corresponding value. The keys can be of any immutable data type. For example, let's say we have a class of students we want to store their final grades of. We can create a variable called student grades and set it equal to curly braces. Then we write down their names. Emma, colon, she'll have a 96% in the class. Emma is the key, and 96 is the value. We'll add a comma to add more students. We can say John, colon, 87, comma, Jenny, colon, 79, and we can go on and on as we need to. To access elements of a dictionary, we can either use the subscript method or a for loop. For this example, we'll use a for loop. For students in student grades, print student grades, and we're going to use the subscript method here, students. When we hit run, you can see that we get the grades of each of these individual students. If we want Emma's grade, for example, specifically her grade, we would put her name in here, and we would get her grade right in here. If we wanted Jenny's grade, we'd just put in her name as the key, and we would get the value from her as a 79%. This is the basic use of dictionaries. They're mutable. You can modify, add, and remove key value pairs even after creating them. And they're commonly used to represent structured data such as records, configurations, or mappings. They provide a convenient way to organize and retrieve data based on specific keys, which makes them a powerful tool in Python. Next, we have tuples in Python, which are an ordered collection of elements enclosed in parentheses. They can contain elements of different data types, and they are immutable, meaning they cannot be modified after creation. They're commonly used to group related data together and can be accessed using indexing or slicing. For example, we can create a tuple named coordinates, and we can set it equal to parentheses 200 comma 200. These would be constants. For example, in some game development, Python or graphical user interface, we might want some values to stay constant throughout the program, and we'd use a tuple because once you create a tuple or define a tuple, you cannot change the values of these, and they would remain. To access elements of a tuple, you can use subscript or for loop. For example, we can say print coordinates brackets 0, and this would give us 200 for the first value, as you can see here. And that's the simple overview of tuples. They are immutable, and that's what makes them different from other data types in Python. Next up, we have Booleans. In Python, a Boolean is a data type that represents either true or false. Booleans are used to perform logical operations and conditional statements in if statements. For example, we can create a print statement that reads 2 is greater than 1. And as you can see, it is true that 2 is greater than 1. We can print the type of this. When we print the type of this, we get class bool, which is short for Boolean. We can also say 1 is greater than 2, which would be false, and that would still be a Boolean. A Boolean is easy to remember. It's either true or false. Finally, we have strings, which is a set of characters enclosed in single quotes or double quotes. It can contain letters, numbers, symbols, and spaces. Strings are commonly used to represent text. For example, let's define a string variable called name and set it equal to the string John. We can print the type of John using the type function. And as you can see, we will get str, which indicates that the name variable is a string. Strings can be concatenated, sliced, and formatted, and much more. They play a crucial role in storing and manipulating textual data in Python. Now that you have a solid understanding of these data types, you can confidently use them in your Python projects. If you found this video helpful, don't forget to like and subscribe to this channel for more Python tutorials and programming tips. Thanks for watching and happy coding.